Hello, everyone. I'm Matt Nohr. I'm an engineering manager for the code creation team. On our team, we've been talking about using embeddings a lot lately, especially related to code. And the idea is if we create this embedding, which is like a representation of the code, uh, then we can find related code faster and provide that to these large language models as we're making code suggestions. We're also talking about how we could use that for the GitLab documentation or search in general. But one of the things that came up at GitLab Summit last week was talking to some people about how we could use these embeddings for issues. So I created a quick proof of concept that I wanted to share with you today on how we could use this. And my goal was to kind of understand the relationships between the issues for the code creation team as I'm doing milestone planning. So I'm not an expert in this stuff. I asked a lot of questions of an LLM, a chat one, to get headed in the right direction. And this is a POC that's not very performant, scalable, even well designed yet, but I thought I'd share just to show some of the power of this. So basically what I did is I used the GitLab API to get all of the open issues for the code creation group. I also used the API to get all the comments for every issue. And then I used an LLM to create a summary. Now, this is something that these LLMs are really good at. I use Anthropic, but all of them would be great. I'll show you that in a second. Then what I did after that is I basically encoded the summary as what we call an embedding. So basically, I took this one issue, and there's a lot more comments below here. I ran it through an LLM, asked for a summary, and on the right side here is what was output. So a much simpler view. I did that because I wanted to kind of consolidate the title, the description, all the comments into one kind of shorter summary that we can compare with each other. Once I had these summaries for each issue, I just ran through and created embeddings for all of them. This is in Python, which has a lot of libraries for these kind of AI functions or these ideas that you want to use. But it was really quite fast. This uses a different LLM here, this paraphrase one. And I just used that because it was easily available and ready to go. And then what comes out of that is I created a not performant way of storing these, but basically just a JSON that has a title, the URL, so I could refer to those later. And then the embedding. You can see here, the embedding itself is really just a long list of numbers, but it's kind of like a unique identifier or a fingerprint for that block of text, which in this case was the issue summary. It's not very efficient the way I wrote it so far. I had about 150 issues or so, and it took about 20 minutes to pull down all the data, create all the summaries, and then create all the embeddings. So it's not something I would do on the fly all the time, but for my case, this POC worked fine. But once that was done, all of these rest of the things I'm going to show were lightning fast. In a matter of a couple milliseconds to do mostly mathematical comparisons between that array of numbers, which computers are experts at. So what I did was try to find a way to group issues. There's a couple different ways you can do that. At the bottom here, you can see all of those issue titles. They're clipped off here, but each one of these is an issue, and this is one visualization of how they're related to each other. So if I were to create, and basically the higher up is how far apart these different issues are from each other. So if I would create just two clusters up here, then all of these issues in orange would be in one group, and all of the ones in green, red, and purple would be in a different group. As you go down, you create more clusters of issues with smaller, kind of more relatable issues. So, and this specific one, based on how far apart the issue is from another issue. And uh, here's an example of a cluster that was created. Um, the summary itself of the issue didn't know anything about the project it was in. It didn't know any existing related issues because I just didn't pull that in. It didn't know anything about labels. All it had was just basically the title, the description, and all the comments, and then a summary of just those. So I was pretty impressed that it came up with this grouping because all of these issues are actually fairly closely related. They all happen to be in the same project, which makes sense. And they all are kind of on the same theme of around how we do dependencies and the repository X-ray project. So already I was pretty impressed. Um, I tried a couple different ways. That hierarchy that I showed before, this one is the one on the right here, and it uses it kind of determines distance is how far apart is how we determine what should be in each cluster. The other one uses this k-means analysis, which is it's an algorithm that kind of minimizes how much variance is within a cluster. I tried these, and honestly, they had very similar results in my case, so I don't think it mattered too much. Another thing that I did then is kind of stored all these related issues to each other. This data structure is gross, and this is not how I would probably do it again. And I might go through and update this. But now, basically, what this gives me is if I'm looking at kind of this first issue, this cannot handle Python dependencies, I have a list of all the related issues. My dream would be to have this kind of right in the GitLab product. Have it. You can currently manually assign related issues, but having another block of potentially related issues would be awesome too. So I did that. Now I can search and find related issues. Another thing I did was try to find duplicates. And this is, you can calculate a similarity score, and which is just another way to analyze those embedding data, which was interesting. In this case, none of these are actual duplicates, but they are super closely related, all of these buckets, and there's a whole long list of these that it came up with. So what I could do now with this then is go into GitLab and actually mark these issues as related. Some of them already are, but yeah, they are very closely related, which is great. Yeah, and this is just the code for finding duplicates. But yeah, that's all I had. Again, this is a really quick and dirty proof of concept, but I got excited about the potential of this, and I used it a little bit to help me plan the current milestone. So thanks for watching. If you have any questions, find me on Slack, reach out to me directly, or write in the G code creation channel, and look forward to interacting there. Thanks, everyone.